Okay, good afternoon all of you. Today this is the last session of class 11 physics till we resume class 11 physics roughly from the month of June. So this is going to be the last session. We will not be having any more sessions. In fact, this is the concluding session of the chapter units and measurements, which we have been doing for the last few sessions. So today's topic is measurement of large distances. So suppose if you want to measure distances which are of astronomical proportions, then how do you do it? And we will discuss that, and of course there will be some homework. Now the method which is employed to measure very large distances, that method has got a name. It is called the parallax method. So let us first discuss what exactly is the method. So suppose there is a very far away planet capital S. Okay, let us say that there is a very far away planet capital S, and I want to measure the distance up to this planet, right? So my target is that there is a very far away planet capital S, and I want to measure the distance up to this planet. So what I will do is that I will take two positions on the Earth. The first is capital A and the second is capital B. So I will take two positions of the Earth, and the distance between these two positions is B. So B is the distance between two positions on the Earth. Okay. So once again, I will be taking two positions on the Earth. One is capital A and one is capital B. And small b is the distance between these two positions. And the planet which I am talking about, capital D, is the distance up to that planet, capital D. And this angle over here, this angle theta is called parallax angle. So once again, there are two places on the Earth, capital A, capital B. The separation between them is small b, and from capital A or from capital B, the distance to a planet is capital B. The angle theta is called the parallax angle, and I need to find capital D. That is what I have to do. So the method is very simple. Actually, the method is that because this planet is extremely far, so we can approximately treat AB as an arc of a circle whose radius is capital D, approximately. So in trigonometry, there is a technique that you can measure angle in degree, but you can also measure angle in radian. So if you measure this angle theta in radian, then the arc length is given by radius into the angle. So small b will be capital D into theta. So this will be the relation between small b and capital D. So small b will be capital D into theta. So this is the method. We can use this method to find the value of capital D. Like small b will be measurable because it is between two places on the Earth. Angle theta can be measured by some instruments, and capital D we can get it by this formula. So this is method one. Secondly, Okay, secondly, what we can do is, once we have found capital D, what we can do is that this planet, suppose the diameter of this planet is small d. Let's say the diameter of this planet is small d, and the angle subtended by the diameter of the planet on the Earth is alpha, and the distance from the planet to the Earth is capital D. So the angle subtended by small d is alpha, this distance is capital D. So once we have found out capital D, what we can do is we can find the diameter of this planet again by using trigonometry. This will be the parallax angle alpha is equal to small d by capital D. So once again, what is the parallax method? If you know the separation between 2 points on the Earth and the angle at a distant planet, you can use this formula to find capital D, which is the distance of the planet from the Earth. Once you have found capital D, you can have another situation like this. The diameter of the planet small d is not known. In this case, the parallax angle is alpha. You want to find the diameter of the planet, so you can use alpha equal to small d by capital D. So these are the two methods which are collectively known as parallax method, and they are used to measure astronomical distances. So okay, the first homework question is that capital A and capital B are 2 points on the surface of the Earth, and the distance between them is 1.276 into 10 to the power 7 meters. So capital A, capital B are 2 points on the surface of the Earth. The distance between them is 1.276 into 10 to the power 7 meters. And at the moon, they are subtending an angle of 1 degree 54 minutes. So what is the distance of the Earth from the moon? So this is the first homework question, right? So the distance between capital A and capital B is this. The angle subtended at the moon is this. So the question is that what is the distance of the Earth from the moon? That is the first question. Okay, the second question is that you have to say what will be the diameter of the sun if the distance from the sun to the earth is 1.496 into 10 to the power 11 meters. Okay, the distance from sun to earth is 1.496 10 to the power 11 meters. what is the diameter of the sun if this angle subtended is 1920 seconds. So that is the second homework question from this topic. The distance from sun to earth is 1.496 into 10 to the power 11 meters. So what is the diameter of the sun if the angle subtended of the earth is 1920 seconds. So these are the two questions which are homework questions, and you can submit the homework anytime by 9 p.m. tomorrow, that is Wednesday. And I'll end this session now. In fact, like I told you, this is the concluding session of class 11 physics till the end of your board exam. So that's it. I'll conclude now. Bye all of you.